All right, guys. So today, we're back at it again. A lot of information to go through. We're going 10.6 today. Find the segment lengths in a circle, aka they're called power theorems. And the reason they're called power theorems is because there's a lot of multiplication going on. So be prepared for quadratics and a bunch of other things that go with this because we're basically doing powers here. All right, so first things first, let's get some definitions down so we know what we're talking about when we look at it on diagrams. All right, so the first thing is when two chords intersect in the interior of a circle, each chord is divided into two segments called the, and very basic here, segments of the chord. Segments of the chord. All right, so here we go. Segments of a chord theorem. So here we go. I'll draw two chords and they intersect, and I'm going to go A, B, C, D, and their intersection point is E. All right, so if two chords intersect in the interior, because remember, they can't intersect on the circle, which would make inscribed angles, and this wouldn't apply. If they have two chords which are in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Basically, what this is saying, guys, is that if you were to take the segments of one chord, multiply them together, it is equal to the multiplication of the segments of the other chord together. So we can write this as AE times EC is equal to BE times DE, or ED. So chord segment times segment equals the segment of the other two chords. All right, so let's look at a couple examples here. So we have first one, find X. Find X. So we have two chords that intersect, and we see along this chord here, I just put the red dots on, is we have X and 4. So we're going to take 4, and we're going to multiply by X is equal to, in my other case, my other chord is 8 and 5, so 8 times 5. So very simply, 4x equals 40, x equals 10, and that's how we solve it. Pretty straightforward. All right, let's add a little complexity here. Now, here are my two segments. My first chord, 12x and 5x, so we're going to multiply those together. 12x times 5x equals, then we got 6 and 10, so 6 times 10. So we see we have 60x squared equals 60. Divided by 60, we get x squared equals 1, and then we take the square root of that. We get x equals positive 1 and negative 1. Because remember, when we do square root of both sides, it's always plus minus. However, you got to make sure that your answers work in the actual reality. So positive 1 works. It gives you 12 and 5. But if you plug in negative 1, that gives you negative 12 and negative 5. So this is what we call an extraneous solution. It's a solution to the problem, but it doesn't actually work when the problem is set forward. Because again, we cannot have negative length. So you can't have negative 12 and negative 5. All right, let's look at the bottom one here. A lot more going on here. All right, my first segment, I have x plus 4 times x plus 3. Now we're starting to see a lot of the our algebra skills come back. And 10 and 21, 10 times 21. So it's going to be a little bit of work to us, okay? So we need to FOIL or multiply out by two binomials here. So we get x squared plus 3x plus 4x plus 12. First, outer, inner, last equals 210. All right, I'm going to move everything to the left-hand side and combine like terms. I'm just going to do it all at once. So x squared combined like terms is plus 7x And then when I subtract 210, I get minus 198 equals 0. And we're looking at this and going, oh my gosh. I have 198, and I got to see if that factors. And you go, wow, man, that's a big number. I don't really like that one. Well, you can start going through the multiples. But I'm going to help you out here, guys. Little trick you can see with 3-digit numbers is if the first number and the last number add up to the middle number, it's divisible by 11. And it works only in 3-digit numbers, right? First number, last number adds up to 11, or adds up to the middle number, is divisible by 11. So this one's actually divisible by 11. It's pretty nice. And it ends up being 11. And here's the cool thing. The number it's multiplied by is the end numbers. So it's 11 and 1 and 8, so 18. So you know you're going to have 11 and 18. And if you think about it, guys, how do you get positive 7? Well, that'd be plus 18 minus 11. And that now equals 0. So that's a pretty cool trick with 11s. And it works for some 4-digit numbers, but you got to be very careful because it's hard to do it. It's easier when you're multiplying by 11 to go, oh, split the numbers, add them together, that's your middle number, and if you have anything over 10, you just add it to the first number. So it's a little bit harder, but when you're trying to divide, that's the easy trick to it. So here we get x equals 11 and negative 18. And of course, you have to say, all right, looking at my problem, do they both work? Now, 11, of course, gives us 15 and 14, so that works. But if you plug in negative 18, that's negative 14, negative 15. Yeah, no, can't have negative distance. So again, negative 18 is extraneous, and so x equals 11. So be prepared, guys. You're going to see, your quadratics. So be able to solve by square root or factoring, or in worst case scenario, the quadratic formula. All right. So that's if we have two chords. However, we know that's not the only scenario what happens with lines that intersect with circles. So let's look at our other scenarios. So the next one is if a secant segment is a segment that contains a chord of a circle and it has exactly one endpoint outside the circle. So guys, what we're talking about is given a secant segment. Now again, remember, secant is a line that goes through the circle, intersects at 2 points. So it keeps going on and on forever. So what we're talking about is if we just took the segment. And what you see here is that when you take a secant, and we discussed this earlier, that a secant creates a chord on the inside. So here's my chord right here. Here's the chord part. And then you also have this exterior part out here, right? And then, of course, we have the whole thing. And you're going to hear me use exterior and whole a lot, right? So, given that, the part of the secant segment that is on the outside of the circle is called the external segment, which I just referenced, the external part, and I use EXT just to write it out. All right? And then, of course, guys, that's not the only line that intersects a circle that goes on the outside. We also have the tangent segment. Just to make sure we know what that is. So we have secant segments, we have tangent segments, and then, of course, we have two chords intersecting in the center. So that takes care of all the lines that possibly be there that we've discussed before. So let's go with the theorem that goes with it. If two secant segments share the same endpoint, which means they touch outside the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So a good way of putting this, guys, is when we're looking at it. Oops, sorry about that. Is that we have two secants, one there and one there, and they meet at this point way out there, right? I'm going to call this E, and then it has the points of intersection along the circle. We have A, B, C, and D, right? And what this is telling us is that if we look at each one, guys, we have our first secant EB and our second secant EC, and it says that since they intersect at a point outside that circle, that EB times EA, right? EB times EA or EA times EB, either way you want to put it, external times the whole, external whole, right? And I like to call it the whole because it's easier than saying the whole secant, is equal to the same thing on the other side, ED times EC. So when we're dealing with secants, guys, and we're looking for lengths of secants, we always want to do the external part of the secant times the whole thing. So there may be times where you're given part of it. There may be times you're given the whole thing. You may be given the inside and the whole. You have to find the outside. So a couple of different scenarios you're going to see. All right. So this is how we're going to work. External times whole, external times whole. Keep that in mind as we're going to just keep that mantra up. All right. So here are my examples here. All right. We want to find x. Well, we have two secants, and they give us the segments for the external part and the inside chord. And you go, all right, well, I need the external part. So my first one, that's x minus 4. However, what's the whole thing here? Well, that would be x minus 4 plus 15. And if you realize that's x plus 11. And then we got to do the same thing over here for x minus 3 and 11. That's x minus 3 plus 11. So my external part of that one is x minus 3. And then the whole thing here is x plus 8. And that allows me to get my equation where I can solve. So now I got to do my multiplication, my FOIL, first, outer, inner, last. So that's x squared plus 11x minus 4x minus 44 equals, do the same thing on the other side. X squared plus 8x minus 3x minus 24. And then we can start combining like terms and then solving. X squared plus 7x minus 44 equals x squared plus 5x minus 24. And what we'll notice is that, I got x squared on both sides. So if I subtract those out, those go away. And now I'm left with 7x minus 44 equals 5x minus 24. So I'm going to move all my x's to the left and all my numbers to the right. So this is going to end up being 2x equals 20. So x is equal to 10. Easy answer on that one. We like that. That's a nice one. And it makes sense, guys, because it's 6 times 21 and 7 times 18. And if you multiply those together, they actually do equal the same number. All right. Let's look at the second one here. So again, external part, and then give us the inside. So here we go. We want to find the whole thing. In this part, this one, 8 and 13 give me 21, and 7x and 17x give me 24x. Because you're adding them, not multiplying them. So we look at it. Let's start with the x secant. 7x times 24x, external part times whole, equals 8 times 21. Well, that's not too bad. It's numbers and numbers. So 7 times 24, that's 140 plus 28. That'd be 168x squared equals 8 times 21. That's 168. Oh, man. Lucky us. Divide by 168, you get x squared equals 1. Square root both sides, you get x equals 1 and negative 1. But again, we got to check our answers. Again, we see x negative 1 is extraneous because, again, we cannot have a negative distance. So x equals 1 is my only answer. Be aware, though, that if you end up sometimes that the negative might work. So be aware. It could work. So just make sure you're checking. All right, here we go. Last one. Same process. We have external and internal, right? Let's start with the numbers, the easy one. The external part's 9. The internal part's 7. So that means the whole thing here is 16. This is where most students get confused at, is that they start going, oh, external times internal. No, remember, it's external times whole. So in this case, FD would be x minus 4 plus x minus 2. And then that, to us, is 2x minus 6. So keep that in mind, because that makes a big difference in terms of how we calculate. All right, so x minus 4 times 2x minus 6 equals 9 times 16. Yeah, quadratics, here we come. FOIL, 2x squared minus 6x minus 8x plus 24 equals 9 times 16, which is 144. Combine like terms, 2x squared minus 7x. I'm going to bring the 144 over because, again, I want it equal to 0 to solve. And that gives me negative 120. Oops, I put 7x. I meant 14x. My bad. Now, normally we ask you to factor this point, but guys, if you notice that each term is divisible by 2, right? So let's divide everything by 2. That includes the 0. Because that gives me x squared minus 7x minus 72 still equals 0. And that's a lot easier to factor than 2x squared minus 14x. Because now, if I look at that, oh, minus 7 minus 72. Well, 9 and 8 would be the first thing I'd come to, but that's not going to quite work, right? And then I got 6 and 12. Not so quite there. What other numbers? Well, we got 36 and 2. We got to just figure out which one of these factors is 72. If you really rack your brains, right, you're going to end up with, oh, I did something wrong. My bad. This is where I went wrong. I'm so apologizing. I did some bad math here. It's not 144. It's 120. I knew I got something wrong. Which means this is minus 60. That's a lot easier to solve. Factors of 60, that makes sense. Well, that, if you get it, is minus 12 plus 5. I'll take my bad on that one. Bad math. Here we go. So x equals 12 and negative 5 respectively. And again, if we plug in negative 5, we see we get negative numbers. That is extraneous. So again, math teachers are people too. We do make mistakes. All right. So we see we get that. All right. So we still got one more theorem to go, guys. One more theorem, because we talked about secant, but we didn't talk about secants and tangents. We've already done tangent. Remember, we did that on the first day of class, and we said two tangents to the same circle are always congruent. So we don't have to worry about that theorem anymore. We know that's true. All right. Secants. If a secant segment and a tangent segment, share an endpoint outside a circle, then the product of the lengths of the secant or external segment and its the secant segment and its external segment So just like we were just doing, as I said, all secants are always external times whole, equals the tangent or the square of the tangent segment. So if we have this, and we have this, and I'll call it W, X, Y, and Z. And we see that we have secant WX or WY, there's my secant segment, and we have the tangent WZ. What it's telling us is that the secant segment times its external part, so WX times WY, is equal to my tangent squared. So WZ squared. And that's my formula. And if you think about it, guys, the tangent acts just like the secant. It's external times whole. Well, with the tangent, the external part is the whole segment. So therefore, it's the external times the whole, which is the same thing, which is the same thing squared. Hopefully that makes sense. So let's look at some of our practical applications. So we still got to do the same thing with our secant. We have an external part and an internal part. We do need to combine them. So in this case, this becomes x minus 4 plus 1, which is x plus 1. So if we do it, it's x minus 4 times x plus 1 equals x minus 2 squared. Okay, tangent squared. All right, so we got to do foiling on both sides. We got to multiply them out. So we get x squared plus x minus 4x minus 4 equals, and if you remember, this is x minus 2 times x minus 2. That gives me x squared minus 2x plus 4. I'm going to combine like terms real quick. X squared minus 3x minus 4 equals x squared minus 4x plus 4. We see that the x squareds on each side, they are going to subtract out. So I'm going to go ahead and cross them out. And I'm going to move all my x's to the left and all my numbers to the right. And when we do this, we see we end up with x equals 8. Oh, man. Whew. All that work, we get one nice number. And if you plug it in, guys, you get 4. And the whole thing would be 9. 4 times 9 is 36. And if you plug in 8 for the x one, 8 minus 2 is 6. 6 squared is 36. So you see their values are equal. And that does an easy way to check it. All right, let's look at the second one here. All right, so my secant is 2x plus 5 and 48, and my tangent is 4x plus 1. So again, we need the whole thing, so that's 2x plus 5 plus 48, and so that's 2x plus 53. Woo, that's going to be a big number. So here we go, 2x plus 5 times 2x plus 53 equals 4x plus 1 squared. And I hope you're up to date on how to do foiling. So let's make sure we got it. All right, here we go. First, outer, inner, and last. Here we go. 4x squared plus 106x plus 10x plus 5 times 53 would be 265 equals 4x plus 1 times 4x plus 1. That's 16x squared plus 4x plus 4x plus 1. All right, combine like terms. 4x squared plus 116x plus 265 equals 16x squared plus 8x plus 1. All right, since my 16x squared is my biggest number with powers, I'm going to move everything to the right. So I'm going to subtract 4x squared. I'm going to subtract 116x. And I'm going to subtract 265. Not going to be pretty on one side, but we're going to make do. So that's going to give me 0 on my left equals 12x squared minus 108x minus 264. Now, if we notice here, right, that all my numbers are even, so we know it's divisible by 2. I can take out a 2. And if you really think about it, they're all divisible by 3 as well. So I could pretty much take out a 6, and it may be possible that I could take out a 12. But let's start with the 2, and then we'll go with the 3. So if I take out a 2 out of everything, divide everything by 2, that's going to give me 6x squared minus 54x minus 132. Then I'm going to divide everything by 3. So that's going to give me 2x squared minus 3 into 54 is 18. And then 3 into 132 would be 44. And look, I got all even numbers, so it is divisible by 2. So 0 equals x squared minus 9x minus 22. Man, all that work, and I get back to something that's very, very easy to factor. Factors of 22 that add up to 9. That'd be x minus 11 times x plus 2. And so we get x equals 11 and negative 2. And again, if we plug in negative 2, that's not going to work. That's extraneous. So 11 is my answer. A lot of work, but we get down to a nice number. Thank gosh. All right. And the last one, here we go. AB. So same thing. Tangent's 2x. My secant is 2x plus 3 and 15. We need the whole thing here. So x plus 3 plus 15, which is x plus 18. All right, so starting with my secant, x plus 3 times x plus 18 equals 2x squared. Do my FOIL. X squared plus 18x plus 3x plus 54 equals 4x squared. Combine like terms. X squared plus 21x plus 54 equals 4x squared. And I'm going to move again everything to my right, because that's where my highest power is. And that's going to leave me with 0 equals 3x squared minus 21x minus 54. And then I'll notice that, oh, those are all divisible by 3. Let's divide everything by 3. So that's going to be 0 equals x squared minus 7x minus 18. Hey, I like that numbers. X minus 9, x plus 2. So in this case, x equals 9 and negative 2. And again, if I plug in negative 2, that's extra again. That's extraneous. So 9 is my answer. I know it's a lot of information to take in, especially since last class, but guys, it is what it is. Practice, practice, practice is what's going to make this better. And again, until next time.